Hello everyone, welcome back to the YouTube channel of Functional Safety First. This is part 2 of our videos on verification of software SEooC. If you have not watched part 1 yet, make sure to check that out before you see this one. In our last video, we explained about the complexity of the external world of a software SEooC, like how a software SEooC may be assumed to work in a wide variety of microcontrollers, operating systems, different kinds of architectures, and different types of compilers. With this understanding of the complex world of a software SEooC, let's come back to the question that we are trying to answer. How do I know that I have sufficiently verified my software SEooC? Let us firstly understand what is verification. Verification is a means of determining whether an object, which is in our case the software SEooC, meets its requirements. Not only when it is standalone, but it should also meet its requirements when it is integrated into a system. So verification has two aspects, static and dynamic verification. Static verification includes activities such as reviews, walkthroughs, and static code analysis. Dynamic verification is done via testing and includes various levels of testing such as unit testing, integration testing, and functional testing. Static verification of a software SEooC includes activities such as reviewing the software component and its static code analysis. However, it is not within the scope of the SEooC to ensure that it is integrated correctly in the system in which it is used. To go back to our CRC library example, while you may do review and do static analysis of the CRC library, it is not within your scope as the SEooC developer to check whether the CRC APIs are called and used correctly in the system. So the correct call of the CRC APIs, such as ensuring that if there is an init API, it is called in the right init container of the system, must be taken care by the system integrator. Similarly, the system integrator must ensure that the right parameter values are passed to the CRC APIs. So, by writing these external verification measures in the safety manual, the SEooC developer can ensure that these measures are informed to the system integrator. To summarize, the software SEooC developer has to clearly specify the rules for correctly integrating the software component, and if they do that, then that is sufficient enough to cover the static verification aspect. So these rules could include things like 1. Ensuring that the APIs are called correctly. So for example, if the SEooC has 3 init APIs and these APIs have to be called in a certain order, then this must be defined as a rule in the safety manual. Similarly, if there are timing dependencies or dependencies with APIs of other software components, this must also be defined in the safety manual. Number 2 is ensuring that the right value is passed as parameter to the APIs. Though the SEooC may never be able to completely ensure that the value that is passed to it is correct, it can define clearly what are the valid values for each of its parameters in the APIs and when to pass which value. So example, when the valid values for parameter 1, what is the valid value for parameter 2, and so on, and when to pass which value so that the integrator can call the API correctly. Again, coming back to our example of CRC library, let's assume that there are two applications, E2E and memory check. So in both E2E and memory check, the system integrator is using the CRC APIs. Now, the system integrator has to ensure that the CRC API is called correctly and the parameters passed are correct in both the components. So just doing it in one wouldn't be sufficient. Number 3 is ensuring that any special data sections that are required to store some of the data of the SEooC in a specific memory region or to do any processing in a separate memory region are created in the system. Number 4 is clearly describing the configurations and calibrations involved in the software component. Incorrectly configuring the software component is not in the hands of the SEooC, but for sure it will fail when it is configured wrongly. Number 5 is defining rules for freedom from interference. So the SEooC must not be interfered by a lower SL component in terms of timing, memory, or communication. So additional measures must be placed in the safety manual for the system to implement these safety mechanisms to achieve the FFI for the SEooC. Now that we covered the static verification part, let's move to testing. Typically, assuming that the SEooC has one or more software components, unit testing of each of these components is within the SEooC scope. Integration testing between the software components of that SEooC is also within its scope. So for example, if you're supplying memory check and CRC components as an SEooC, and if your memory check is using the CRC, then you have to perform the integration testing between memory check and CRC. However, that's how far it can go. An SEooC can never fully test its functionality as it will be tested in an actual system in which it is integrated. So any integration testing that's done with the external components or any kind of functional testing in a system can only be done by a reference system. You can only do it within a reference system, but not with an actual system as far as an SEooC supplier goes. So the system integrator who is using the SEooC is responsible to ensure that the SEooC is integrated correctly in that system and its functionality works as per the requirements of that system. So the SEooC supplier should clearly mention these external testing assumptions in the safety manual. Now let's talk about another aspect of testing, that is, how should we choose the reference system in which I test my software SEooC? Should I test my CRC library in Infineon or TI or NXP or Qualcomm? Or should I test it in AutoSAR OS or QNX OS? Testing in one microcontroller does not substitute for testing in another. So you cannot test the CRC library in Infineon and say confidently that it will work in TI. This is because so many aspects of a micro, such as the CPU's instruction set, clock speed, address and data bus width, NDNS, etc., can influence the final functioning of exactly the same piece of code differently in different micros. Even between variants of the same micro, say different families of Infineon, you cannot confidently say that the software component will work in all of those variants unless you have tested it in all of them. An exception could be made when you have made a detailed impact analysis between the different families to be able to confidently conclude that testing in just one variant of the micro is sufficient. Similarly, testing in one OS does not substitute for testing in another. Testing in one compiler does not substitute for testing in another. Hence, test the software SEooC in all the microcontrollers, operating systems, compilers, software and hardware architectures in which it is going to be used. When it comes to the compiler, it is not only the compiler itself that is important, but also the compiler options that were used while developing the software component. And these options have to match exactly in the system in which the software SEooC is integrated. To summarize in short, number one, you can only verify what is within the scope of the software SEooC. Number two, you should test the SEooC in all the external software, hardware, and system aspects that can influence its behavior. And number three, you have to delegate the verification at the system level to the system integrator by writing those requirements in the safety manual. That's it for this video. I hope we have helped clarify the questions of the software SEooC developers. If you have any further questions on this topic, please feel free to reach out to us at autofunctionalsafety@gmail.com or leave a comment in the box below. Thank you for watching.